Hello everyone. Today's topic of discussion is similar figures. We will first talk about the properties of similar figures. That is, we'll understand what makes two figures similar to each other, and then we will work on an application problem to apply the properties or knowledge of similar figures. Now, two or more figures are considered similar if their corresponding angles are equal to each other. And it's only that the corresponding angles are equal. Their sides are not necessarily of the same length, but as long as their corresponding angles are equal to each other, the figures are considered similar. And it could be any figure, any polygonal figure. It could be triangles, it could be quadrilaterals, pentagons, hexagons, any polygonal figure. As long as their corresponding angles are equal, they are considered similar figures. Now I'm going to draw two triangles. I'm going to work with triangles here, and I'm going to show first what we mean by corresponding angles. So here we have two triangles, triangle ABC, and then we have triangle EFG to the right. And as we can see clearly that these two triangles are of different sizes. Triangle ABC is much larger than triangle EFG. However, they can be considered similar triangles if their corresponding angles are equal to each other. So first, let's identify what the corresponding angles in these two triangles are. The corresponding angles would be angle A, all right, angle A would correspond to angle E, all right, and then angle B up here would correspond to angle F in the smaller triangle, and then angle C would correspond to angle G in the smaller triangle. All right. So if the corresponding angles are equal, and I'm going to write that down here, if angle A equals the corresponding angle E, and if angle B corresponds to, if angle B is equal to the corresponding angle F, and if angle C is equal to its corresponding angle G, then triangle ABC and EFG are similar. All right, then they are similar. Now there's another very important and useful rule that applies to similar triangles, which helps one solve many geometry-based application problems, is the rule about the ratio of corresponding sides in similar triangles. So the corresponding sides in similar triangles are proportional. What it means is the ratio of the corresponding sides will always be equal to each other. So first, let's identify the corresponding sides in these two triangles, all right? So I'm going to pull up a color here, a different color for this purpose. So the side AB corresponds to the side EF in the smaller triangle, and the side BC corresponds to the side FG in the smaller triangle, and the side AC corresponds to the side EG. All right, so these are corresponding sides, and the rule or the property says that the ratio of the corresponding sides are equal to each other, which means if we take EF and divide it by AB, it's the ratio, correct? So EF divided by AB will be equal to the ratio between FG and BC. So will be equal to FG divided by BC, which will be equal to EG over AC. EG over AC. All right. So that is the other property, all right? And so in similar triangles, not only are the corresponding angles equal, the corresponding sides, or the ratio of the corresponding sides, are all equal as well. And we say, which is the same thing really as saying the corresponding sides are proportional. But one other thing is we can also write this proportion as AB over EF. All right, we can switch the numerator and the denominator, put the sides of the bigger triangle in the numerator and the sides of the smaller triangle in the denominator. All right, so we can write it as BC over FG equals AC over EG. All right, they mean the same thing. All right, we can write it in both ways and it'll mean the same thing. We will now work on an example problem that will apply the properties of similar figures. Now, previously, when I was explaining the properties, I was using triangles as examples. However, these properties apply not only to triangles, but any polygonal figure where the corresponding angles are equal. All right, they would be considered as similar figures, all right, whether it's a three-sided triangular figure, or a four-sided quadrilateral figure, or a polygonal, any other polygonal figure would satisfy these properties as long as they are similar. All right, now that given, let's work on this example problem. It says here triangles ABC and EFG are similar triangles. So they've already told us that they are similar triangles. So we can go ahead and use the properties that we learned for similar triangles to solve this problem. But what is this problem asking us for? It says, determine the length of side EG in the smaller triangle. So we have triangle ABC, and the sides, all the side lengths are given to us for triangle ABC. However, for the smaller triangle EFG, we are only given the measure of one side, which is FG, and that's 5 centimeters. So given this information, we have been asked to find the length of side EG. All right, so this is the side length that we have to find given this information. So we are going to use the property of similar triangles, where we were told that the ratio of the corresponding sides of similar triangles will be equal to each other. So let's identify the sides that are similar in this picture. So side AB corresponds to side EF, and then side AC corresponds to side EG, and the side BC corresponds to the side FG, correct? So we have to set up an equation using the ratio of the sides of the corresponding sides. So first, let's set up the problem with the ratio of the sides. So we are going to have AB, right? AB will be equal to, or rather AB over EF, that's its corresponding side, will be equal to AC over EG. So AC over EG will be equal to BC over FG, which are corresponding sides. So BC over FG. All right, so we have to set up an equation where EG is it's the unknown side, but it has to figure in the equation. Otherwise, we cannot solve it, correct? So let's pick this one here. All right, this has to be in our equation. We don't need all three ratios. All right, we'll just pick the one whose side we have to find, and another ratio which has both sides given. So in this, for this problem here, BC and FG, these two corresponding sides have their values given to us. So I'm going to use the one which has BC and FG. So these two are the ones that we are going to use. We can ignore A, B, and EF. All right. This one we'll cross out. Okay. So AC is, AC is 7 centimeters, right? So I'm going to write 7 over EG. EG is what we need to find. So I'm going to say EG. Just keep it as EG because we don't know the value of that. And then we have BC, which is 13 centimeters. And then FG, in the denominator, the value of it is given 5, correct? So we can have only one unknown in an equation, and that's why we chose the two ratios which would have the values of all other sides except the one that is unknown, EG. So now we just have to solve for EG. Now in this case, it's best to cross multiply. All right, it's like solving a simple algebraic equation. So I'm going to cross multiply. So 7 times 5 is 35, and 13 times EG is equal to, so just cross multiply, all right? If you're wondering how to solve this, just cross multiply. So 13 times EG, all right? When we cross multiply, that's what we get. And we want to now have the EG by itself on one side and get the 13 over to the other side. How do we do that? We divide both sides by 13. All right, both sides by 13, and we end up with EG equals 35 divided by 13 is approximately 2.69, rounded to the second decimal place. All right, so I'm going to write it like this. 35 divided by 13 is 2.69. You can use your calculators to do that division. All right. So this is how we apply the property that the ratio of the corresponding sides in similar triangles are equal to find the value of a missing side. All right.